Okay, so before we jump into 2.2, we will do the exercises that were listed at the end of the last video, which was to find the domain, range, and graph for two functions, the first of which was x squared minus 1. And here the domain is simply all real numbers because you can square any number and subtract 1. There's no restrictions there. The question really is, what is the range? And for that, it suffices to graph this, and you can see that this is going to be a parabola pointing upwards, where you're going to have a couple intercepts here at plus and minus 1, for example, but even though it's not really relevant for this problem. But you do have those two intercepts. And all that's going to happen, well, what y values come from this? Well, any line that crosses all the way down to negative 1. So it's going to be negative 1 and everything above it. So negative 1 to positive infinity is our range for that one. That was the first exercise. The next exercise was to take the square root of x minus 2 and then add 1. And here you can check that the domain, well, you need x minus 2 to be 0, so it's everything larger than 2, or 2 to positive infinity. And hence, if you plug in 1, 2 here, and then go to 1, you'll get a point right here, and that's sort of your starting point, and you get this sort of shape. And here, the range, well, any line that that's at least over here, which is the line y equals 1, any line above that should do. So here your range is positive 1 to infinity. Okay, so that's the exercises from the end of the last video. We're going to dive into 2.2, which talks about the graphs of some more functions, of, I would say, key functions. And I'm just going to list some of them here. So some of them include y equals x squared, y equals the absolute value of x, y equals the square root of x. These three we have seen already. And then we have y equals x cubed, y equals 1 over x, y equals, we'll say plus or minus the square root. This is an example of a type, 9 minus x squared. And then we have something called a piecewise function. We'll see what that is in a moment. So what we're going to do in this video is essentially just graph exactly these four examples. So let's start with y equals x cubed, and we'll go from there. And we'll try to state the domain and range for each of these as well. So let's start with y equals x cubed. And rather than making a chart, I'm just going to do some key points sort of verbally here. We have the point 0, 0. If you plug in x equals 0, you get y equals 0. If you plug in 1, you get out 1. Right? 1 cubed is 1. If you plug in x equals negative 1, you get negative 1 cubed, which is negative 1. Let's do maybe one more point here. This is the point 2. If you cube 2, you get 8. So 2, 3, 4, 5, 6, 7, and 8. So we're way up here. And if you take negative 2, negative 1, negative 2, 3, 4, 5, 6, 7, and negative 8 is somewhere here. Then you get a point negative 2, negative 8. And you get this, this kind of graph right here. So this is the graph y equals x cubed. And you can see visually that the domain here, if this is f of x, the domain is everything. And so is the range. The range of f is also everything. Okay, so this is This is our first example of a, I think, relatively newer function, x cubed. Let's look at plus and minus the square root of 9 minus x squared. So we actually have two functions here, but they turn out to be very much related. Before I get to this, let's start off with an equation that at the moment, well, hopefully it looks kind of similar. Maybe not exactly the same. Let's look at x squared plus y squared equals 9. Now this, if you remember from section 1.9, this is the equation of a circle. Here's r squared, which is 9, so r is 3, and we're centered at 0, 0. So we have a circle of radius 3, right? This is 0.30, this is a 0.03, and so on and so forth. So this is a circle of radius 3. And so you say, well, let's solve for y. Let's solve for y. So y squared is 9 minus x squared. You can see this 9 minus x squared there. So if you solve for y, you get plus or minus the square root of 9 minus x squared. And we say, well, how do we relate that exactly to the circle? Well, let's look at each part separately. Let's take first the positive square root of 9 minus x squared. Now, we actually saw, well, even aside from anything else, this is all the y's here are positive. We have a positive square root. These are going to be positive values. Well, what are the positive values here? So these are all y, pretty much y is positive. So this corresponds to the part of the circle where y is positive. Well, where is y positive? It's right here, right? This top half of the circle. So this actually corresponds to the top half of this circle. So if we were to graph this, we would just have this top part right here. From -3 to 3, that would be the graph for that part. Exactly similarly, if you looked at the negative square root, well, if you're taking a negative of a square root, here y is negative. Y is negative. And, well, what is the negative part of the circle? The negative part of the circle, that's going to be the bottom half of the circle. So we're going to get the bottom half right here, again from -3 to 3. So this is the bottom half of a circle. So whenever you have the square root of a number minus x squared, positive or negative square root, then you're going to correspond to the top and bottom halves of circles. And the circles are going to be of radius the square root of this particular number. Okay, in this case, the square root of 9 is 3, and the radius of this circle, full circle, is 3. So this is an important example. It comes up, I think there's a problem or two on WebAssign that deal with that function as well. Let's go to the next function, which is, for that particular one, I forgot to mention here. So for here, the domain is -3 to 3. Notice this y value here is 0, the y value is 3. So the range here is, well, the smallest y value here is 0, and you go up to 3. Whereas here, the domain is still -3 to 3, but the range, the highest y value is 0, and the lowest y value corresponds to this point, which is -3. Whoops, sorry, -3's got to go first. -3, comma 0. Okay, so that's the domain and range for each of those. We're going to jump here to this graph. This particular one is a little bit, it's a little bit different than the others. So notice this is This is a what's called a rational function. Okay, whereas the other ones, basically this has a denominator. None of the others had x's in a denominator. All the x's were in the numerator. Whenever you have quotient, like a fractional thing with polynomials here, these are called rational functions. So this is the sort of most basic rational function. And let's plug in a bunch of x values here, because this one is going to be a bit different than the graphs that you'd seen. So let's plug in, say, -1, -2, -3. Let's do -1/2 as well. And then let's do a +1/2, +1, +2, and +3. That should give us some idea of what's going on. Okay, so when we plug these in, x equals -1, 1 over -1 is -1, 1 over -2 is -1/2, 1 over -3 is -1/3, 1 over -1/2, that's -2. 1 over a +1/2, that's 2. 1 over 1 is 1, 1 over 2 is 1/2, and 1 over 3 is 1/3. So these are some points that we're going to graph here. So we have 1, 2, 3, -1, -2, -3, 1, 2, 3, -1, -2, -3. So let's start with this. We have -1, 1, -2, -1/2. Whoops, I'm sorry. This is wrong. -1, -1, -2, -1/2, -3, -1/3. And then here is -1/2, which maps up to -2. Similarly, here we have 1, 1, 2, 1/2, 3, 1/3, and then let's plug in a half here, and that outputs 2. So it turns out actually that what's happening, if you keep going, right, if you plug in 4, you're going to get a 4th. So 4, you're going to get a 4th. You're going to get a very, very small number here. Similarly, at -4, you're going to get a very small number. So these, on this side, on the one hand, when you're getting, x is getting large, the y values are getting really, really small. Okay. And on the other hand, the same thing is happening as x becomes negatively really large. Like if you have -5, -6, -7, you're tapering off. So notice here you have this sort of tapering towards the x-axis. And here also you're tapering towards the x-axis. In a similar way, if x is really small, so say I plugged in x equals 1/3, y would be 1 over 1/3, which is 3. And analogously, with the -1/3, we have 1 over -1/3, which is -3. You see that you get these points, so if you have a third here, you have a point up here. And similarly, you'd have a point here, -1/3, -3. So here, these things are, this is going towards, it's going to go towards positive infinity because it's growing. And the graph is getting very close to the y-axis. Similarly here, you're going towards negative infinity. It's moving towards negative infinity, and you're getting closer and closer. You're never actually going to touch, right? It's never going to actually touch the y-axis here. Notice why is that? Because you can't plug in 0. Notice x cannot be 0 here. We cannot divide by 0. So there's no y value corresponding to x equals 0 because 0 is not part of the domain. So what you have is it's a special kind of situation where the graphs are getting closer and closer to this y-axis. And so we say that this y-axis is called a vertical asymptote. And what that means is literally that we kind of draw this as a dot. We think of it as kind of a dotted line where the graph gets infinitesimally closer and closer to that particular axis. That's called a vertical asymptote. Analogously, the x-axis right here, since we're tapering towards, we're getting closer and closer to the x-axis. Here also we're getting closer and closer there. The x-axis is what's called a horizontal asymptote. So there's a lot of stuff that's going on just with this one rational function. So let's actually stop here and leave you with an exercise, which is going to be something similar to what we just did, and that is going to be to graph y equals 1 over x minus 1. And you want to label, at least I would say label several points, as well as in a similar way, you're going to get a vertical and a horizontal asymptote. Just like here, the vertical asymptote was the y-axis, the horizontal was the x-axis. In a similar way, you'll get asymptotes here. Go ahead and label that, and we'll start off with the next video with that exercise.